Welcome back. We're continuing our series on solving linear systems by substitution. So let's dive into a few more examples. We have minus 5x minus 2 equals y plus 3. And we have minus x minus 2 equals 2y plus 1. Okay, so this is our linear system of equations. And we have equation 1 and equation 2. Now recall, when we're using the substitution method, we want to take one equation and solve it for one variable in terms of the other. All right, so let's go ahead and, let's just take the first one because it looks much simpler. Let's go ahead and solve this system, or this equation for y. So we have minus 5x minus 2 equals y plus 3. And actually, we only have one thing to do here. We can subtract both sides by 3, which will cancel these two terms. So if we flip it, we have y equals a minus 5x. Minus 2 and minus 3 is minus 5. So we have one of our variables, y, in terms of the other variable, x. So all we do is we substitute this expression into the other equation wherever we have y. So let's go ahead and do that. Switch colors, we have minus x minus 2 equals 2 times y, which is the expression minus 5x minus 5. Then we have our plus 1 on the end. Okay, so let's go ahead and distribute a few things. Let's distribute this minus sign into this parentheses, this 2 into these parentheses. So we're going to have a minus x plus 2 equals 2 times minus 5x is minus 10x. 2 times minus 5 is minus 10. We have plus 1. Okay, so now we have an equation to solve that it just involves one variable, which is what we want, and we want to find a value for it. So let's go ahead and move our x terms to the left and everything else to the right. So we're adding 10x to both sides. We can go ahead and subtract 2 from both sides in the same step if you would like. These two terms cancel, as do these two. So we're left with 9x over here. Minus 10 and minus 2 is minus 12, plus 1 is minus 11. And let's just go ahead and divide both sides by 9 to isolate x. So we have x equals minus 11 over 9, and we have a value for one of our variables. Once we have this, all we have to simply do is plug this value into either equation, plug in minus 11 over 9 in for x. So let's go ahead and just choose equation 1 again. It looks a little bit more simple. So we have minus 5 times x, which is minus 11 over 9, minus 2 equals y plus 3, and now we can simply solve for the value of y and be done with it. So we can cancel these two negatives, so we have 55 over 9 minus 2 equals y plus 3. Let's go ahead and isolate y by subtracting 3 from both sides. These two terms will cancel, which gives us y equals 55 over 9 minus 2 times 3, or excuse me, 2 and 3. Minus 2 and minus 3 is minus 5. We want to rewrite it as a fraction with the denominator of 9, so we have 45 over 9. And we can simply combine these fractions in the next step. So we have 55 minus 45 is 10 over 9, and that's our value for our y variable. So this was, we ran through this one, but we should be getting very familiar with solving linear systems by substitution. Now all we have left to do is to write our answer. So let's go ahead and stick our answer up here. This is the exact solution for this system of equations. We're not graphing anymore, so we're not playing with approximate solutions. These are exact solutions. So we have our x value is minus 11 over 9. Our y value is 10 over 9. And again, we can check this by plugging these two values in for x or y, and either equation, they'll both work. So that's how we know that that's the point where those two lines intersect. All right, let's do another one. We have x plus 1 minus 7 equals 5 minus y plus 1. That's equation 1. The second equation we're given is 3x 3x minus 3 over 2 equals minus 9y plus 5 halves. Okay, these both look pretty nasty. This one even more so because they have fractions in it, and these have parentheses in it. So we're going to have our work cut out for us one way or the other. So we have equation 1 and equation 2. And what we want to do is we want to solve one of the equations for one variable in terms of the other. So let's just go ahead and bite the bullet, take equation 1, and let's solve it for x. So we have x plus 1 minus 7 equals 5 minus y plus 1. All right, let's take care of the parentheses. We can actually drop the parentheses over here since there's no multiplication or distribution going on. So this is just addition and subtraction. So x plus 1 minus 9, or excuse me, minus 7. We can distribute this minus 1 into the parentheses here. Recall it's a minus 1. Or if you just want to drop the parentheses and change both the signs, you can do that. It's the same thing. So 5 minus y minus 1. And now we have our variables on both sides, so we just need to combine like terms here. We have x, 1 minus 7 is minus 6 equals minus y. We have a 5 and a minus 1, which is plus 4. And let's go ahead and add 6 to both sides so we can solve for x. We could have solved for y here and used that the same, but it doesn't matter either way. So x equals minus y plus 4 plus 6 is 10. So we have an expression. We have x defined in terms of the variable y. So let's go ahead and substitute it into equation 2 and find a value for x, or excuse me, a value for y. We'll be dealing strictly with y. So let's do that. We have 3 times x. X is minus y plus 10. We have our minus 3 halves equals minus 9y plus 5 over 2. Okay, so let's go ahead. This is exactly what we want. We have an equation with just one variable in it, so we can isolate our variable to the left, everything else to the right, and we'll get a value for y. All right, so let's go ahead and do it. We can distribute this 3 into the parentheses here. So we have 3 times minus y is minus 3y. 3 times 10 is 30. We have minus 3 halves equals minus 9y plus 5 halves. Okay, we want our variables on one side, so let's go ahead and bring this over to the left. We can add 9y to both sides. Let's go ahead and move this fraction over to the right in the same step. We're adding 3 halves to both sides. These two terms cancel, these two terms cancel. So we have 9y minus 3y is 6y plus 30 equals 5 plus 3 is 8. 8 over 2 is simply 4. Let's go ahead and subtract both sides by 30. So we have 6y equals 4 minus 30 is minus 26. And we can simply divide both sides by 6 to isolate our variable y. So we have y equals minus 26 over 6, which will simplify to minus, if we factor out a 2 out of the top and the bottom, we have minus 13 over 3. And that's our value for y. So now that we have one variable solved for, we can substitute, once again, this y, this minus 13 over 3, into the first equation, or actually in either equation, but in this one we're going to use the first equation so we don't have to deal with fractions. We're going to substitute this value in for our variable y and solve for x. So let's do it. We have x plus 1 minus 7. I always like to rewrite the equation no matter what we're going to do in the next step. So we have 5 on this side minus y is minus 13 over 3. Let's put that in parentheses in itself because we're substituting. I like to get in the habit of that. And now we can simply solve for x. We saw above that we can drop the parentheses here. So we have x plus 1 minus 7 equals 5. We're going to distribute this minus sign into the parentheses. So we have a positive 13 over 3 and a negative 1. Positive 13 over 3 and a negative 1. All right, and the rest is cake. So we have x plus 1 minus 7 is minus 6. We have 13 over 3. 5 minus 1 is plus 4. We're just combining like terms. I like to combine ones first that are easier to deal with before we deal with fractions at the end. We can isolate x by by adding 6 to both sides. So we have x equals 13 over 3 plus, 4 and 6 is 10. Let's go ahead and rewrite that as 30 over 3. So we have a common denominator here, and we can take care of these fractions by combining them in the next step. So we have 43 over 3, and that's our value for x. So let's go ahead and write our solution, or the exact solution to our system of equations. We have 43 over 3 and minus 13 over 3. This is the exact point on the graph where these two equations, the equations of the two lines described by these two equations, intersect. And if you plug in these two values in for x and y, both equations will remain true. So we're continuing to solve linear systems by substitution. We'll do one more video on just looking at a few more examples, and then we'll move on to a few applications where solving linear systems by substitution would actually be very useful. So I'll see you in the next video.